Good morning, my dear children. Today we are going to discuss linear equations. Linear equations. Previously, we have solved the differential equations in two methods. That is, what is the first one? Separating the variables method, and the second one is homogeneous differential equations. Now we are going to discuss third method, that is linear differential equations. Linear differential equations. Linear differential equations. Here there are two types of linear differential equations are there. Here first one is dy by dx plus p into y is equal to q. This is one kind of linear differential equation, and another one is dx by dy plus p into x is equal to q. These two are said to be linear differential equations. In this exercise, we are going to solve these two types of differential equations. Here where p and q are some functions in x, here in this case here where p and q are these two, the letter P and the letter Q, capital letter P and the capital letter Q denotes there are some functions in x or some constants. There may be constants also. Whereas in this type of differential equation, here P and Q, P is nothing but here coefficient of x here Q is nothing but the quantity which is written in the right side of the equation. These two, here P and Q are some functions in y. These two letters, capital letter P and capital letter Q, are some functions in y. Means it may be cos y, sin y, y square. It may be any function, log y. Similarly here, it may be a function in y or some constant, 100 or secant square y. In this way, these two letters denotes some functions in y or some constants. So in this exercise, we are going to solve these two types of differential equations. These are said to be linear differential equations because here what is the degree of this linear equation? Degree is 1 and order is also 1. This is also first order, first degree. So these two are two types of linear differential equations. We are going to solve these two types of differential equations. Whatever the differential equation is given, we have to convert the given differential equations in any one of these two forms. These two are said to be standard forms of linear differential equations. These are said to be standard forms. These two are said to be standard forms of linear differential equations. Got these 2 points, my dear children? Understood this point? This differential equation and this differential equation. These two are said to be standard forms of linear differential equations. We have to convert any differential equation in this exercise. We have to convert first into these forms. Got this point? Understood this point, my dear children? Say, respond.
Okay, sir.
Okay. This is about standard forms of linear differential equations. Now, the second point, this is the first point about linear differential equation, and the second point, how to solve, how to proceed to solve a linear differential equation of any type, this type or this type, any type. Okay, what are the steps to be followed? Okay, remember these steps carefully, my dear children. Very easiest method, only 3 steps. We follow only 3 steps. You have to remember these 3 steps. Okay, shall we go to the next point? Can we go to the next point? In the second point, we are going to discuss how to solve.
సార్ స్టక్ అవుతుంది. స్ట్రక్ అవుతుంది.
నెట్వర్కా?
ఏమో సార్, మీ కెమెరా స్ట్రక్ అవుతుంది.
I'll check. I'll check. I think it is okay.
ఇప్పుడు బానే ఉంది సార్. ఇందాక మీరు చెప్పేటప్పుడు స్ట్రక్ అయింది.
Maybe some network issues maybe. Okay, now we are going to discuss the second point, that is how to solve a linear differential equation. Second point, the second point is how to solve a linear differential equation. How many types of differential equations, linear differential equations are there? How many types of linear differential equations just now we discussed here? We discussed here 2 types of linear differential equations. Yes or no? So, first, step 1. Step 1, we have to write the given differential equation. Step 1. I am not writing full form. Here D dot E stands for differential equation. So we have to write the given differential equation in the form of dy by dx plus p into y is equal to q. As I said, this is a standard form of a linear differential equation of type 1. Similarly, here also we follow the same step. Step 1, write the given differential equation in the form of dx by dy plus p into x is equal to q. As I said, where p and q are some functions in x or constants, where p and q are some functions in x, or these are constants, maybe some constants. Similarly, in this type, here p and q stands for where p and q are some functions in y. In this type of linear differential equation, here p and q stands for there are some functions in y or some constants. Okay, this is the step 1. We have to follow these steps when we are solving a linear differential equation. Now step 2. We have to find integrating factor. In the short form, we write as capital letter I, F, capital letter F. Integrating factor. We have to find integrating factor. You have a doubt, what is the integrating factor, sir? How can we find? There is a formula, integrating factor. E power integral p dx. This is the integrating factor of a linear differential equation of type 1. Similarly, we follow the same step here. Step 2, find integrating factor. What is this one? What is this one? Integrating factor. In the short form, we can write it IF. For this type of linear differential equation, integrating factor is equal to e power integral p dy, because p and q are some functions in y, as we said. So we take integration with respect to y only. This is the second step. We have to find out integrating factor by using this formula. In this type, second type, we use this formula and we find integrating factor. Okay. Now the last step, third step, step 3. General solution. We write the general solution of the general solution. Directly we can find out the general solution of the given differential equation of this type. that is y into integrating factor, as we found integrating factor in the second step. Okay, so y into integrating factor is equal to integral integrating factor into q dx plus c. This is a general solution of linear differential equation of type 1. Similarly, here step 3, we follow this step 3. So we write here general solution of the linear differential equation of this type, that is x into, in the place of y just we write x, in the place of dx we write dy, that's all, remaining as it is same. So here y is there, so write here x into integrating factor is equal to integral integrating factor into q dy plus c. So these 3 steps, we follow these 3 steps to solve a linear differential equation of type 1 and type 2. You have to remember these 3 steps. That's all. Very simple concept. In this exercise, we are going to solve linear differential equations. There are only 2 types of linear differential equations. This is type 1 and this is type 2. Okay. To solve the linear differential equation of type 1, that is dy by dx plus p into y. Okay, always we have to find out p and q when you are solving. It is very important. So y is nothing but p is nothing but coefficient of y in this case. Whereas in this case, here p stands for coefficient of x. Coefficient of x only. Okay. Now, after writing the given differential equation into the standard forms, as I said, these 2 equations are said to be standard forms of linear differential equations. Okay, so we have to write the given differential equations in the standard forms. And second step, we have to find integrating factor. In the short form, we write IF. For this type of linear differential equations, integrating factor is nothing but e power integral p dx. Whereas in the second type of linear differential equation, integrating factor is equal to e power integral p dy. Got this point, my children? Got it? Please respond to my questions, yes or no. Say yes or no. Are you there in the class? Nobody is responding. Rohit, Sindhu, Sai Eknath, Nikhil.
Sir, చెప్పండి.
Are you there in the class or not? Simply just respond to my question, Nikhil.
Okay, sir.
So step 3. This is a general solution of a linear differential equation of type 1. That is nothing but y into integrating factor is equal to integral of integrating factor into q dx plus c. Similarly, in the second type of linear differential equation, general solution is x into integrating factor is equal to integral integrating factor into q dy plus c. Okay, you have to remember these 3 steps only. Again, here we have to find integral of this function in RHS. In RHS we have to evaluate this integral. Okay. Can we go to the next point? Exercise sums. This is only the concept for this exercise. Can we go to the exercise sums? Will you take a screenshot? Will you take a screenshot?
ఓకే సార్ ఓకే తీసుకుంటాం.
తీసుకోండి. Just I will wait for 1 minute. Make it fast, take a screenshot. Then I will start exercise sums. Have you taken the screenshot?
Yes, sir.
Yes. Now exercise sums. Exercise sums. You have to remember these 3 steps only. Okay. Now exercise 9.6. Exercise 9.6. See the first question. Let us take the first question. Question number 1. Given differential equation is dy by dx plus 2y is equal to tan x. First question, second, third and fourth. These 4 of same type. 4 of the same type means, I mean, the given differential equations are in the standard form itself. No need to worry about first step. The given differential equations is itself in the standard form. Okay. Now, by comparing the given differential equation with dy by dx plus p into y is equal to q, we have, tell me what is p and what is q. We compared the given differential equation. We compared the given linear differential equation with this standard form. The given linear differential equation itself, it is in the standard form. Now tell me what is p and what is q. P is nothing but y coefficient and q is nothing but after the is equal to sign, that is tan x. So first step is over. Okay, this is the first step, the given linear differential equation itself in the standard form. Now we go to the second step. What is the second step? We have to find integrating factor. Step 1, this is step 1 itself. Step 1. Step 2. We have to find integrating factor, IF. For this first type of linear differential equations, integrating factor is e power integral p dx. Remember, you have to remember this integrating factors and the general solution. Okay, so e power integral p, what is p here? 2. So 2 dx. So e power 2 into integral dx. This is equal to e power, what is integral dx? What is the value of integral dx? X only. Therefore, so in the step 2 we found integrating factor, that is e power 2x. Okay, now step 3. Step 3, general solution of given differential equation. What is the general solution of the given differential equation? Y into integrating factor is equal to integral of integrating factor into q dx. You have to remember this general solution of a linear differential equation of type 1. You have to remember integrating factor and general solution. Okay, now we substitute integrating factor and q in this general solution. This implies we write y as it is, y into, what is integrating factor? E power 2x is equal to integral e power 2x into, what is q here? Tan x. Tan x plus c. Plus c, we write at the last only, general solution last, we can write plus c at last only. So here we had to evaluate this integral. By which method we can evaluate this integral? By which method? Tell me. How do you find integral of this function? By which method? You learnt several methods, various methods. How do you find the value of integral e power 2x into tan x? Integrating by factor. Do you remember integrating by factor? This is exponential function and this is a trigonometric function. Do you remember isolate integral by parts? So these are not in the particular order. So integral tan x into e power 2x dx plus c. Now we arrange the two functions in that particular order, isolate, trigonometric function and exponential function. Now hereafter we use the integrating by parts. What is the formula? This is f of x and this is g of x. Integral f of x into g of x dx is equal to, what is that? First function, that is tan x into integral g of x dx minus integral d by dx of tan x integral e power 2x dx whole dx. Here we integrated this function by using the integrating by parts method. Integral f of x into g of x integral f of x into g of x dx is equal to f of x into integral g of x dx minus integral d by dx of f of x into integral g of x dx whole dx. By using this formula, we integrated this function. Okay, here f of x is nothing but tan x and g of x is nothing but e power 2x. That is equal to tan x into integral e power 2x dx. What is the value of integral e power 2x dx? Tell me. Tell me integral e power 2x dx. E power 2x by 2. Okay, minus integral d by dx of tan x. D by dx of tan x. Secant square x into e power 2x by 2 whole dx. Got this one? Then e power 2x by 2 into tan x minus 1 by 2, we write 1 by 2 outside, into integral secant square x into e power 2x dx. Again we use the integrating by parts. Again integrating by parts. Trigonometry and exponential. Again we use integrating by parts method. Okay. So let us assume this is I. Okay. Let I is equal. This is equation 1. Because again we have to integrate this function. So we are assuming this as capital letter I. So let I is equal to integral secant square x into e power 2x dx. Again we use integrating by parts method, trigonometry and exponential. Okay, tell me, this is f of x and this is g of x. F of x into, so secant square x into integral e power 2x dx minus integral d by dx of secant square x into integral e power 2x dx whole dx. Okay, again we use integrating by parts method. This integration part only little bit lengthy. Again and again sometimes we have to use integrating by parts method. Okay, yes. Secant square x into e power 2x by 2 minus integral d by dx of secant square x. What will you get? Tell me. Tell me. D by dx of secant square x. 2 secant x into tan x. Yes or no? So in this way we find this is right side integral and we substitute its value in the equation 1. Then we get the solution of this differential equation. This is a type 1 sum. Okay. Take a screenshot. Take screenshot. Will you try that remaining part? integral. Will you try that remaining part? I value. Find the I value and substitute I value in the equation 1. Okay. So question number 1, 2, 3, 4. These are all first type of sums only. These are all first type of sums only. Try the questions 2, 3, 4. Okay. The given differential equations themselves in the standard form. Okay. Take the screenshot of this question and find I value. Okay, you can find the I value and substitute this I value in the equation 1. Have you taken it? Completed? Can we go to the next question? Question number 5. You try the question number 2, 3 and 4. Here nothing but integrating by parts method. We are using integrating by parts method. The general solution of linear differential equation. Hereafter, after this step, we are using integrating by parts method only. Nothing else. Nothing a new point. Do you have textbook in front of you? Have you opened the textbook in front of you? Have you opened the textbook? So question number 1, 2, 3 and 4 are of the same type. These 4 questions directly the given differential equations are in the standard form only. Okay. As we followed the 3 steps for solving the first question, here also you follow the same 3 steps. Okay. Now I am going to start question number 5. Can anyone read the question number 5? Can anyone read the question number 5? Cos square x dy by dx plus y is equal to tan x. This is only question number 5. 0 less than or equal to x less than or equal to pi by 2. This is only the question number 5. Cos square x into dy by dx plus y is equal to tan x. Is this question number 5 in the textbook, in your textbook? This question only. Observe this linear differential equation. This is not in the standard form. What is the standard form? First term must be dy by dx only. In the linear differential equation, in the standard form, first term should be dy by dx only. Its quotient always 1 only, not any other number. But if you observe dy by dx quotient is cos square x. Here dy by dx coefficient is cos square x. So we divide this entire equation by cos square x. Dividing, first of all we are converting this differential equation into the standard form. Okay, that is why dividing the above equation by cos square x. Then what will you get? If you divide this entire equation by cos square x, directly I am writing dy by dx plus y by cos square x. Y by cos square x. Yes or no? Y by cos square x. So plus y secant square x. Can we write it or not? So secant square x into y. Directly I am writing secant square x into y is equal to tan x by cos square x. What will you get? Tan x means sin x by cos x. Okay, we will write sin x by cos x. We are dividing by cos square x. So 1 by cos square x. Otherwise we can write tan x into secant square x. Tan x into secant square x. Okay. So directly I am writing tan x into secant square x. Now the given linear differential equation converted into the standard form, that is dy by dx plus p into y is equal to q. By comparing the above differential equation with dy by dx plus p into y is equal to q. Tell me what is p here? P is equal to y coefficient, that is nothing but secant square x, and q is equal to tan x into secant square x. So this is the first step. We converted in the question number 1, 2, 3, 4 the equations themselves in the standard form. ఆల్రెడీ మనకి ఇచ్చిన లీనియర్ డిఫరెన్షియల్ ఈక్వేషన్స్ స్టాండర్డ్ ఫామ్లోనే ఉన్నాయి. క్వశ్చన్ నెంబర్ 1 నుంచి 5 వరకు, 1 నుంచి 4 వరకు. క్వశ్చన్ నెంబర్ 5, 6, 7, 8, 9 ఈ 5 sums not given in the standard form. First we have to convert them into the standard form. After converting them into the standard form, we have to find what is p and what is q. So this is the first step. Okay, now we are going to start second step. Second step is nothing but integrating factor. This is step 1 only. Step 1. Now step 2. Integrating factor. That is equal to IF. What is the integrating factor of a linear differential equation of type 1? E power integral p dx. Okay, so e power integral, what is p here? Secant square x. So secant square x dx, that is equal to e power integral secant square x dx. What is integral secant square x dx? Tan x. Okay, so we got integrating factor. Second step is over. Now step 3. General solution. General solution of the given differential equation. What is the general solution of the given differential equation of type 1? Y into integrating factor is equal to integral integrating factor into q dx plus c. This is called general solution of a linear differential equation of type 1. Okay, this implies y into, what is integrating factor? E power tan x is equal to integral e power tan x into, what is q here? What is q here? Tan x secant square x. Tan x secant square x dx. So hereafter we use integrating by parts method. Integrating by parts method only. Okay, so let us assume this is equation 1 and we take this is as I. So that I is equal to, let us assume that this is equation 1. Let I is equal to integral e power tan x into secant square x dx. We have to integrate this function. Integrating by parts method only. We use here integrating by parts method only. And moreover, we can use the substitution method also. If you take tan x as t, let us take tan x is equal to t. So put tan x, let us assume this is 2. Put tan x is equal to t. By taking differentials on both sides, what will get? Tan x derivative secant square x into dx is equal to dt. We substitute these two values in the equation 2. Therefore, I is equal to integral e power tan x means e power t into tan x means t secant square x dx. Secant square x dx means dt. So we simplified this complex function into a simple function. Now we can use again integrating by parts method. But the functions are not in the same order. This is an algebraic function, this is an exponential function. We rearrange integral t into e power t dt. First function f of x is t and g of x is e power t. So first function t into integral e power t dt minus integral d by dt of t into integral e power t dt whole dt. This implies t is into integral e power t only minus integral d by dt of t 1 only integral e power t dt. Again e power t integration is e power t. So t into e power t minus e power t. Again we substitute tan x in the place of t. Okay, then we get the general solution of the given differential equation. Will you do the remaining part of this solution? Will you do that? Will you substitute again t value tan x? Okay, will you take that screenshot? Please do that remaining part of this solution, and moreover you try the question number 6, 7, 8, 9. All these are of the same type of questions. Take screenshot. Take a screenshot. Take screenshot.
Sir.
Yes, Nikhil.
Sir, wait, sir.
Time over, huh?
Time over కాదు సార్ నా దాంట్లో ఛార్జింగ్ అయిపోయింది.
Okay. I will stop the class. I will stop the class now. I will stop the class. Okay. Rohit. Sai Eknath.
సరే సార్.
Sai Eknath.
సార్.
Take once attendance. Okay. Take the attendance once. Who attended?
ఎక్కువ మంది లేము సార్ 8 మెంబర్స్ ఉన్నారు.
ఇందాక ఉన్నారు కదా నిఖిల్. ఇప్పుడే కదా నిఖిల్.
అది నాకు తెలియదు సార్ వాళ్ళ గురించి.
ఓకే, ఇప్పుడు ఉన్నంత వరకు తీసుకో అటెండెన్స్. ఓకే. Okay, take a screenshot and do that remaining sums 5, 6, 7, 8, 9. All these are of the same type of questions. Again 3 or 4 o'clock. Can we take 4 o'clock?
సార్ సండే సార్ ఈరోజు.
సార్ ఈరోజు చాలు సార్. బాయ్ సార్.
బాయా?
ఎంజాయ్ చేయండి సార్ ఇంట్లో వాళ్ళతో ప్రశాంత్.
అదే ఏంటి సార్ మీరు సినిమాకి తీసుకెళ్ళండి అందరినీ. ఏంటి
సరే వెళ్దాం. ఏ సినిమాకి వెళ్దాం?
మీరే చెప్పండి ఏ సినిమాకి వెళ్దాం.
ఏమో మీ ఇష్టం చెప్పండి, దాన్ని బట్టి మేము వెళ్దాం, ప్లాన్ చేద్దాం.
మీరు ఎలా అంటే అలా సార్.
ఓకే ఓకే ఆలోచిద్దాం. ఈలోపు ఇక్కడ రాసిన బోర్డు మీద 5, 6, 7, 8, 9 are all same type of questions. You try that 5, 6, 7, 8, 9.
సరే సార్. టైం అయిపోయింది. బాయ్ సార్. సార్ నేను ఎక్సిట్ అవుతున్నా.
ఎగ్జిట్ అవ్వకు, జస్ట్ నోట్ చేసుకొని వెళ్ళిపోండి.
ఓకే సార్. బాయ్.
Try these questions.
బాయ్ సార్.
Bye, Nikhil. You can exit. All of you can exit. You can leave. Rohit.